Hello, this is Mr. Henry, and welcome to lesson 5.5. This is the last lesson of this module on functions. So make sure you have, the normal stuff done, notebook, your center question, your warm-ups, your homeworks, all that stuff is ready, good to go for our test coming up here shortly. So this lesson will be describing relationships from graphs. The center question says, how do I describe fundamental relationships from graph? And that fundamental means like the basics of the graphs. Okay, and our warm-up, we have a type 1 with 2 minutes on the clock. It says, give an example of a scenario that could be represented by a function, either as a graph, a table, or an equation. So I'm looking for a scenario, a word problem. You don't have to write out the whole problem, but give me an example of something that can be represented using from a function either as a graph, table, or equation. Okay, go ahead, pause the video, think about it, think of an example. There's no, as long as you give an example and you're mostly on topic, you're probably right. I'm not going to mark it wrong unless you're way off topic or you just don't answer the question. So pause the video. When you're ready to move on to the vocabulary, hit play. We'll move on together. That's right. Nothing new today. The two vocab words that we're using the most in this lesson are going to be linear function and non-linear function. So you got your linear, which is just basically a straight line. Whoop, linear. You've got your non-linear, which is not a straight line. It could be like this, it could be like this, it could be like that. Okay, so linear, your choices are, it's either increasing or it's decreasing. It's either going up or down. That's it. Well, I guess you can have a zero function like that. For nonlinear, you have the same couple options. You have increasing like this guy, decreasing like that guy, or a combination where some places it's increasing and some places it's decreasing. Okay? And we'll check that out throughout the lesson. So here we have two functions. And by the way, everything we're going to see today is a function. So we have two functions here, and we want to identify what is special about this graph, about letter A. So this graph is, well, is it linear or nonlinear? Oopsie. Clearly, this guy is linear. It's a straight line. So this is linear. Okay? And once we know that it's linear, we can say, well, is it increasing? Is it decreasing? Is it remaining constant? Basically, we're talking about the slope. Is the slope positive? Is the slope negative? Is the slope 0? This guy has a positive slope, so it is increasing. Let's do this. So this is an increasing linear function. There we go. Letter B. Now we have this shape. And let's see. So is it a linear function? No, this would be nonlinear. It's not a straight line. It's curved. So we call this nonlinear function. And now that we know it's nonlinear, is it increasing? Is it decreasing? Is it remaining constant? Again, is it going up, down, or slope of 0? Well, the whole way through, everywhere on this, it's decreasing. It's going down, 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 down. So this is just a decreasing nonlinear function. So that's pretty simple. That's really the first half of the lesson is just this. Okay, here's letter C. So letter C, we have this kind of weird looking thing. It's kind of like a plateau or something. And we want to do the same thing. Well, first off, is it linear or nonlinear? Clearly, this is nonlinear. So it's a nonlinear function. All right. Is this increasing or is it decreasing? Well, this is a little bit of both. From here to here, it's increasing. Now it's decreasing, and now it's decreasing some more. So this is both increasing and decreasing. So this is an increasing and decreasing nonlinear function. We're just describing it. So this is an increasing and decreasing nonlinear. It's not a straight line. It's kind of curvy. Okay, I'd like you to try letter D. So pause the video, put down a description of what this function looks like. When you're ready to continue, hit play, and we'll go through it together. All right, so this guy is clearly not linear, so you're going to say it's nonlinear function. And is it increasing, or is it decreasing, or is it remaining constant? Well, this guy is increasing. It's going up the whole way. There's no point in this where it's going down. So this is just an increasing linear function. Pretty easy. All right, try these two, letters E and letter F. Is it increasing or is it decreasing? Is it linear? Is it nonlinear? Go ahead, pause the video right now, and try these two problems. When you're ready to continue, hit play, and we will go through it together. Alrighty, so this one is both increasing and decreasing. It's increasing from here to here, and it's increasing from here to here. See, it's going up, it's going up. It's decreasing in the other section. It's going down. So this is both an increasing and and decreasing and linear or not linear. Well, if it's both going up and down at the same time in the same graph, it can't be a straight line. Straight lines have constant slope, so this has to be a non-linear function. And letter F. This one is linear. It's a straight line. And let's see, increasing, decreasing, or constant? Definitely decreasing. It's decreasing because it's going down. It has a negative slope. However you want to say it, that's what it is. It is a decreasing linear function. Okay, so these are all just very general. Just looking at a graph, is it going up, or is it going down, linear, nonlinear? Now we're going to start getting into the specifics of the sections of a graph. So here, this is talking about the temperature over 5 days. And we're going to look at the specifics of each little section. So right here, between days 0 and 1, the graph is doing what? So between 0 and 1, what's happening to this graph? Well, in that section, the graph is decreasing because it's going down. That point has a negative slope in that section. Okay? Between days 1 and 2, ignore that little loopy guy on there. But in general, between days 1 and 2, this graph is increasing because it's going up. Okay? And what about between days 2 and 4? Well, here's day 2, here's day 4. Is it going up or is it going down? Well, it wavers a teeny little bit, but overall, I mean, it's staying at 30 degrees for these couple days straight. So this temperature in this range, the graph is constant. Constant means it stays the same, it doesn't change. So in that range, between days 2 and 4, the graph is constant. It's not changing. It's staying 30 degrees for those couple days. I need a new color. Let's do that. Oh, purple. Ooh, I love purple. Here we go. Now, between days 4 and 5, so between here and here, so the end of this, the graph is decreasing again. So now we have this graph broken down into sections. It's not just, oh, this is nonlinear increasing and decreasing. We have between days 0 and 1, the graph is decreasing. Then between days 1 and 2, it's increasing. Then between days 2 and 4, the graph remains constant, or the temperature, we're talking about temperature, the temperature remains constant. And then between days 4 and 5, the temperature is decreasing. And actually, my day 4 is like here. So in that range, it's decreasing. Okay? So now we're looking at each individual section of the graph and being able to describe it instead of just in general what's happening. So the question here says, is the function represented by the graph linear or nonlinear? And explain the reasoning. We're talking about this graph. Is this graph linear or nonlinear? And explain your reasoning. Is the function linear or nonlinear? Okay, so hopefully you said it's nonlinear. And we know it's nonlinear because look at it. It's not a perfectly straight line. It's going up and down and straight and curvies and bumpies and stuff. So it's a nonlinear function. E-C-A-U-S-E, because the graph does not form a straight line. Not a perfectly straight line. Period. It increases and decreases. So that would describe that graph. It's not linear because it's not a perfectly straight line. It's increasing, it's decreasing, there's curves. However you want to describe it, it is definitely not linear. Okay. Now we're going to get to a couple application type problems. This is really where the lesson comes into play because the first part has been so easy. It's like obvious. Now we're going to see about some applications of describing a graph and being able to interpret it. Here, the problem says, the graph shows the money made at a pizza shop on Friday night. Describe how busy the night was in words. Okay, so we've got a little graph here. And let's see. Well, our units are time. I don't know if that's hours or time of day. It looks like time of day. I don't know. It might be hours. And we've got dollars. Okay. So how busy was this night? Well, I mean, between here and here, the slope is pretty steep. Like, it's not just increasing, it's increasing by a lot. I mean, think about it, in this little time span, which looks like each block is about half an hour, because 2 blocks makes 1 hour. So in this half an hour, they made $150. So they made $150 in 30 minutes. In the next time span, between 5 and 6:30, so that was an hour and a half, that's 90 minutes, they only made $50. Let's move all this over here. So in the next time span, in 90 minutes, they made $50. And then in this last time span, between 6:30 and 8 o'clock, which is another 90 minutes, they made let's see, there's $5,200 in 90 minutes. Okay, so this is just kind of some thoughts, brainstorming, describing this a little bit in words, but we need to describe how busy it was in words. And what would you say? Well, I mean, if I was describing this in words, I would say between 4:30 and 5 o'clock, they were extremely busy. Then from 5 to 6:30, the business was slower because they were making less money. I mean, they only made $50 in an hour and a half. That's not very fast. Then between 6:30 and 8 o'clock, it picked up again and they made a good bit of money. So pretty much what I just said is what we need to write out in words. We're describing this in words. All right. My typing is probably going to be quicker than my writing, so let's type here. So between 4:30 and 5 o'clock, what happened? Well, between 4:30 and 5 o'clock, the pizza shop made a lot of money quickly. Then, from 5 o'clock to 6:30, the business slowed down because they weren't making as much money. So from 5 o'clock to 6:30, the shop was making money much slower. At a slower, I know you can't see right now, pace. Let me make it so I can see this all. There we go. And then we can say from, what was it, from 6:30, finally, from 6:30 through 8 o'clock, what happened? Well, the amount of money they made, the rate they were making money, increased because we have this increase right here. It's a faster rate. It's greater rate, so they're making money at a faster pace again. So finally, from 6:30 to 8 o'clock, the shop was making more money again. The shop made money at a faster pace. Now, what I have here is still kind of pretty general. I think we probably do a little bit better, maybe describing. I mean, not just what happened, but maybe we can interpret why this all happened. So between 4:30 and 5 o'clock, why do you think a shop would be making a lot of money? Well, that's like dinner time. I mean, people are getting out of work, they're getting home, it's a Friday night. So between 4:30 and 5 o'clock, the shop made a lot of money because it's dinner time. There we go. Even that just little bit extra helps the understanding of the problem. Okay? Then it says here, then from 5:30 to 6 o'clock, the shop was making money at a slower pace. Well, why? Well, dinner time's done. They're done with the dinner rush. Because, I don't know, Friday people want to get home early. They're not eating dinner as late. Because, I don't know. Because it's after dinner time. And only the people who have late dinners, only the people with late dinners are ordering pizza. Okay. Extend page. Finally, from 6:30 to 8 o'clock, the shop made money at a faster pace. So why did it pick up here? Well, it's Friday night. It's 6:30 to 8 o'clock. What's going to be happening on Friday night? Well, people are going to be getting together. They got home from work. Some people had dinner. Other people are going to get changed and go hang out with their friends. So now, maybe it's Friday night. People are going to start having some parties. They're going to start getting together. People are going to get hungry. So from 6 or 8 o'clock, made at a faster pace because parties are starting. and people want food. There we go. So now not only do we say what happened, we interpreted the graph and explained why that happened. So now we have a graph and a nice explanation. So between 4:30 and 5 o'clock, the pizza shop made a lot of money quickly because it's dinner time. It's the dinner rush. Then from 5 to 6:30, the shop was not making money, or is making money at a slower pace because it's after dinner and only the people with late dinners are ordering. Then finally from 6:30 to 8 o'clock, the rate kicked back up again because parties are starting and people want food. Okay? That's kind of what we're going to be doing. We're trying to interpret what's happening, not just stating the facts that happened. We're going to try to interpret them a little bit and put some reasoning behind the scenario on why the graph looks the way it does. Okay? Letter B. A student commutes from home to school by walking and riding a bus. Describe the student's commute in words. Okay, so we have time in minutes, we have distance in miles. Okay, so if we just look at the graph, we have from here to here, it's increasing. But looking overall of the graph, it's not increasing by very much. So it's kind of increasing slow. So in the first unit of time, it's slow. Okay, and then from here to here, the graph is remaining constant, meaning it's not changing. And then in this third section of time, in a short amount of time, it's going a large amount of distance, which means this person is moving very fast. Short time, big distance, they're moving fast. Okay, so how can we put that in words? What is happening in the scenario to the student commuting from home to school? Why are they moving slow at first, and then they're not moving at all, and then they're moving really fast? Well, student commutes from home to school by walking and riding a bus. Well, walking would fit this. Riding the bus would fit that. So maybe what's happening is in this first section of time, the student is walking. Okay, so let's type this out again. In the first section of time, the student is walking. Okay, I'm going to skip some space here. So we haven't really talked about what's happening in this middle section yet. In the last section of time, the student is riding the bus. All right. So all we're missing now in our explanation, besides maybe some little extra details in here, is what's happening in this middle section. Why is this person like not moving right here? Well, if they walk, then they're waiting, then they ride the bus. They're probably like waiting at the bus stop. That's probably what's happening here. So they're walking to the bus stop. So let's add that. In the first section, the student is walking to the bus stop. In the second section, the student is what? Waiting for the bus. So he's waiting, he's not moving, he's just standing there looking around. And then finally in the last section, the reason why he's moving very fast is now the student's riding the bus. And moving quickly. Let's see, what other details? The first section, the student is walking to the bus stop slowly. The second section, the student is waiting for the bus and not moving at all. And finally, in the last section, the student is riding the bus and moving quickly. So we have here in our description an interpretation of what the graph means. In the first section, he's moving slowly because he's walking to the bus. In the second section, he's not moving at all because he's waiting for the bus. And in the last section, he's moving quickly because he's on the bus and going. The bus is going pretty quickly. Okay? Here's what I'd like you to try. So you have the graph. You don't have the labels or the scenario. So it says here, the graph shows a ferry's trip across a lake. Describe the trip in word. And this ferry is not like a ferry like Tinkerbell. It's like a big boat. And then you get people on the boat and cars and stuff, and you use it to go across a lake. All right? So the graph shows a ferry's, the ferry, the boat, trip across a lake. Describe the trip in words. Go ahead, pause the video, and see what you can come up with. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see. Section 1. We're not moving. Okay, so in the first section, we're not moving. That's not moving. Section 2. We're moving, looks like pretty quickly. I mean, it's a nice slope. It's a pretty good rate of change. So moving somewhat quick. Sort of quick. Moving quick-ish. But over here, look at this. Now in this third section, we're moving really fast because the rate has gone up even more. So now we're moving fast. And then finally in this last section, now we're not moving again. Okay, so that's what we're going to say. We're going to put that down in words. So the first section, we're not moving. Let's delete that. In the first section, the ferry is not moving. Because why? Why isn't it moving? Well, the boat's not going to go for no reason. It's got to like get people on it or get cars on it or get containers full of stuff or something. So it's probably not moving in this first section because people are loading into the boat. Because the boat is loading. Okay? In the second section, the ferry is moving quick because why? So why would the ferry be moving at that speed? I mean, it's moving quick now, but it's moving faster later. So why is it kind of going sort of fast now, but really fast later? I don't know. Maybe they're heading out across the lake because the boat is going across the lake. Boat, lake. Okay. In the third section, the ferry is moving very fast because why? So why would they? I mean, they're moving sort of quick now, and then they go whoa, and they speed up quickly here. Why are they moving that much faster? Maybe they're late. Maybe they've realized that they're running out of time. They need to speed up. One of those sorts of things. They have a set schedule and they're behind schedule. Sure, because the boat is behind schedule and needs to catch up. And then finally in that last section, they weren't moving again. Because why? So why weren't they moving? So let's see. So they're not moving at the beginning. They're going sort of quickly. Then they go really quickly. And now they're not moving at the end. Well, they're probably not moving because they got to the other side of the lake. They got to where they needed to be. And so now they stopped and they are unloading. The last section, the ferry's not moving because they are unloading the boat. There we go. Ooh, why is there an F in there? Because they're unloading the boat. They're taking, the people are getting off, or the equipment's getting off, or whatever it is. That's why they're unloading, or that's why it's not moving. Okay? So we're interpreting the graph in words. Example 4. In an attempt to catch its prey, a cheetah spends 3 minutes stalking its prey at 2 miles per hour. The cheetah then accelerates rapidly to 50 miles per hour over 30 seconds and can sustain this speed for 1 minute. The prey manages to escape the cheetah, and it spends 30 seconds decreasing its speed to a trot of 10 miles per hour and continues at this pace for 5 minutes. Okay? So we want to draw what it says up here in a graph. We want to match what it says. So let's see. Let's look at the graph quickly. So we've got speed in miles per hour. We've got time in minutes. Okay? So let's see here. In an attempt to catch its prey, the cheetah spends 3 minutes stalking its prey at 2 miles an hour. All right, so from the very beginning, it's going to spend 3 minutes at 2 miles per hour. So 2 miles per hour is like here, and we're going to do that for 3 minutes. So it's kind of creeping along at 2 miles per hour. There we go. Then the cheetah accelerates then rapidly to 50 miles per hour over 30 seconds. So over the next 30 seconds, so think, this is 3 minutes and that's 4 minutes. 30 seconds would be halfway. Over the next 30 seconds, it gets up to 50 miles per hour. So I don't know if I could do this on this tablet. It goes up, 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 up. Yeah, there we go. Imagine that's straight-ish or straight more. It's not like going backwards and forwards. So it accelerates quickly to 50 miles per hour over 30 seconds. And it can sustain this speed for 1 minute. So it's going to keep going for 1 minute at this speed. So what's 1 minute from there? Right here. So there he is at 50 miles per hour for 1 minute. It says the prey manages to escape the cheetah, and it spends 30 seconds decreasing its speed to a trot of 10 miles per hour. So it's like running, and this prey gets away, and now it's going to decrease down to 10 miles per hour, which is here. All right, so down, down. Oh, I can do better than that. Down, down, down. I have a line tool, but I don't want to use it. Let's see if I can go up better. Up, up, up. All right, apparently I can go up better than I can go down. All right, so it goes to a trot of 10 miles per hour and continues at this pace for 5 minutes. So 5 minutes from here. So this is at 5. 5 more minutes puts it at 10. So if it's continuing at that pace, it's going at a constant rate. There we go. So our graph now should represent what it said in the problem. Let's see. In an attempt to catch its prey, the cheetah spends 3 minutes stalking its prey. Whoa, what happened? So right here in this section, it's stalking. Then it accelerates rapidly to 50 miles per hour for 30 seconds. So from here to here, we have the chase. So the cheetah speeds up. He's trying to catch his prey. He goes really quickly, and he's able to hold that speed for a minute. So now we're in the chase. And he's running. They're trying to catch each other, and the prey's trying to get away. And then all of a sudden, it says the prey manages to escape. So the cheetah, now defeated, he hasn't got his food. The cheetah just slows down, and it's kind of going at this trotting speed. Defeat. So he didn't get his food, so he slows down. Now he's just running. Maybe he's just kind of walking slowly back to his other group of cheetahs, whatever they're doing. Okay, but we were able to graph the scenario based off what it said in the problem, using our information they gave us. So, a couple questions about this cheetah speed graph thing. It says, what does it mean if the slope of a section is positive? What does it mean if the slope of a section is negative? And what does it mean if the slope of a section is 0? Okay, so when the slope is positive, like here, what does that mean? When a slope is negative, like here, what does that mean? And if a slope is 0, like here, here, and there, what does that mean? Go ahead and put down a response to each of these questions. When you're ready to continue, hit play. We'll go through them together. Okay, so in the scenario we're given with a cheetah, a positive slope would mean that its speed is increasing. So it's getting faster. So the cheetah is moving faster. Okay, so a negative slope would be where the speed is decreasing. The speed is going down over time, so the cheetah is going slower. And then a slope of 0 would mean that the speed is not changing. So that would mean the cheetah is moving at a constant speed for a section of time. Actually, I think cheetah ends in an H, doesn't it? Haha, it does. The cheetah is moving at a constant speed. So, at the beginning, it was moving at a constant speed of 2 miles per hour. It was stalking. It was just slowly moving. Here, it was moving at a constant speed of 50 miles per hour while it was chasing its food. And down here, it is moving at a constant speed of 50 miles per hour as it's just kind of trotting back to its other group of cheetahs, or whatever it was doing. Okay. And for our final summary of this module, it is a type 1. 2 minutes on the clock, and it just says, what words could you use to describe a function? I want a good comprehensive list. In this lesson, we talk about lots of ways we can describe functions, and even throughout this entire module. Give me all the ways you can think of where you can describe functions. That's it. Go ahead, pause the video, make me a nice, good list of all the ways you can use to describe functions. Pause the video if you need the question a little bit longer. If not, this has been lesson 5.5. Thanks for watching.